Hi everyone, in this tutorial you will learn how you can create simple pattern using GLSL POP. So let's get started. Like usual, we will start with a blank new project. The first thing we're gonna bring is a grid pop. We're gonna change the connectivity to point primitive. Next you will attach it to a GLSL, and this is where we will write the code. So you can split the pane here. What I like to do is open a textboard and that, then drag the GLSL compute onto the textboard, then open that, and you can directly edit the code here. If you prefer, you could also edit in any code editor. For example, if you click on edit, I already have mine set to Visual Studio, so when I click edit, it opens Visual Studio. To set that, just go in edit, preference, and then on that's here, you have to change the path to where your code editor points to. I prefer editing directly in TouchDesigner, so it's easier for me. If you click on the textboard, you can also drag the GLSL info and open. So if we have an error, we can easily see what is the error. For those who doesn't know, GLSL stands for Open GL Shading Language, and it's a language used in shader program. In shader program, for example, we will write code to edit pixel, but in our case we will use the GLSL to edit the position of every points in our grid. We will jump into the code. So the first thing we want to do is store the position of the points. So we will declare a vec3, we call it pause, and we want to get the points depending on the grid. So to do that, we have to use the TD notation, which is TD in P, and then we only have one input, but we have to select it, so input 0 and then ID. Now that we have every coordinate of each point, we want to know the distance between the center and each point. So in order to do that, we will declare a float, call it dist, and this will be length of position. With that, we will be able to create a pattern using the distance. So for example, we can say that dist is equal to sin of dist, and then we can give it an amplitude, and we will divide it by 4 just to make it more stable. Now we don't see anything happening is because we need to tell the new position to the P attribute. So we will uncomment this, and then we will change it for pause, which is our initial position, times the distance. Now we have an error. You can see P is undeclared is because we have to output it in the GLSL. So go into the GLSL and output attribute and select P. Now we can see we have a pattern, but there's no movement. In order to create movement, we have to create a new vector that we will call uTime. It will be a float, and then we will use the time bar to reference our time. So the formula is me.time.frame divided by 60. Now we will add this uTime to our code. So let's go back to the code, and then we can add the uTime to our sinus equation. Now we can see that we have this wave motion. Now there's really an infinite thing of things you could do to make this look more interesting, but this is kind of beginner friendly tutorial, so I don't want to get into complex GLSL, but for example you could just change it to cos. You could also, for example, multiply the distance by the exponent of minus the length, which give another kind of pattern. I'll let you discover what you can do with this GLSL code, but if you know basic math, then you can do amazing things. Now to make this more interesting, we will create a constant job. We will have one constant call and one constant call row. Right click and view. We will use it later, so let's keep it here. On the grid, just drag the calls on the call and the rows on the rows. You could also have more slice, which make it more like 3D. We will attach it to random and change the combine operator to set. We will have a row attribute. Then let's grab a lookup texture, copy and paste, so we will have two. Okay, now what we want to do is instantiate our points with a box. So let's grab a box, reduce the size to 0.1 and the uniform scale to 0.02. Grab a copy. The first input will go with the box and second input the lookup. So now we have our points. What I want to do is to rotate individually each box so it doesn't look that bland or flat. So I will go into the random and I will change the value A to minus 360 and value B to 360. In the copy template, enable the rotate template. Now we can see that every box has its own rotation. It's a bit big, so I'm gonna reduce to 0.1 maybe. We can do the render network now so we can see what we're doing. Let's grab a geo, camera, light, and render top. Change the pixel format to 32-bit float. In the render, put the alpha to 1, attach it to a null, make the viewer active, and we will just bring this up. Oh, too much. Now we will change the scale and the color of the points. I want to keep the kind of sine motion for the scale and the color, so what I will do is I will bring a ramp. I will change the type to circular. In the common, I will also change the resolution to match the points. And in the ramp, I will decrease the period to 0.15. In the lookup texture one, I will drag it, and then I will change the output attribute scope to point scale. In the copy, we have to enable the point scale. Let's add a material. Choose a phone. Reduce the diffuse and increase the specular. Okay, I will just reduce the number of columns for now. Okay, we could also change the ramp a bit, so just add another bar here, and we'll bring that to white. And the third one here, if you click on it, we'll just bring this to black. We can drag it to the lookup texture too, and we will change the color. So color, and in the copy, go to template attribute, enable the use template point attribute, and select color. Okay. Now this looks good, but it's a bit like the color is static, and then the point scale is also static. So what we can do is animate the phase here. It goes from -1 to 1. So we can have a pattern trap. We will keep the sign and change the length to 600 to match the timeline. Attach it to a time slice. No. And in the ramp, just reference the null in the face. So now we can see it's already more interesting. The last thing we can do is just to bring a bloom. Then change the output to bloom, the pre-back level 0, and the min bloom radius also 0. I like this kind of bloom effect on my visual. Can bring it a little bit further. And if you want, you can add some color. So in the ramp, you could just, so instead of white, you can just have a bit of color. You can also increase the points. Then we can reduce a little bit point size. But that's the end for this tutorial. So as I say, it's a very beginner way of using the GLSL. If you would like to have more complex GLSL tutorial like this video or comment, I will link this project file on my Patreon, so you can get it there if you want. Thanks for watching.